Good evening, friends, and welcome to Sleepy Time Tales, a podcast aimed at helping you to get a good night's sleep. This is a podcast where I read old books, sometimes fiction, sometimes non-fiction, in the most boring way I can, to try help slow your spinning mind, enough for you to fall asleep in the most natural way possible. The stresses of life often follow us to bed and keep us company, but I'm here to distract you from them and help you to drift away. But before you do fall asleep, if you find Sleepy Time Tales helpful and you'd like to support me to keep it going out to you and thousands of your fellow insomniacs, please consider supporting on the Patreon at patreon.com/sleepytimetales. You can also put a tip in the tip jar in the Ko-Fi, which is linked in the show notes. Or you can support Sleepy Time Tales by simply spreading the word. If you know someone struggling to sleep, just tell them about it. And that's enough of that. Let's start learning about solar eclipses and the sun's corona. We return this week to Astronomy, the Science of the Heavenly Bodies by David P. Todd. Chapter 30, Total Eclipses of the Sun. Primitive peoples indulged in every variety of explanation of mysterious happenings in the sky. To the Chinese and all through India, a total eclipse of the sun is caused by a certain dragon with very black claws, who, except for their frightening him away by every conceivable sort of hideous noise, would most certainly eat up the sun. The eclipse always goes off. The sun has never been eaten yet. Can you convince someone that Rahu the dragon wouldn't have eaten up the sun if his unearthly din hadn't frightened him away? In Japan, the eclipse drops poison from the sky into wells, so the Japanese cover them up. Fontenelle relates that in the middle of the 17th century, a multitude of people shut themselves up in cellars in Paris during a total eclipse. In the Shu King, an ancient Chinese work, occurs the earliest record of a total eclipse of the sun in the year BC 2158. The Nineveh eclipse of BC 763 is perhaps the first of the ancient eclipses of which we possess a really clear description on the Assyrian eponym tablets in the British Museum. It is the eclipse possibly referred to in the Book of Amos. But of all the ancient eclipses, none perhaps exceeds in interest the famous eclipse of Thales, BC 585, May 28th. It is the first eclipse to have been predicted, probably by means of the Saros, or 18-year period of eclipses, which is useful as an approximate method even at the present day. But the accident of a war between the Lydians and the Medes has added greatly to the historic interest, because the combatants were so terrified by the sudden turning of day into night that they at once concluded a peace cemented by two marriages. Very many of the ancient eclipses have been of great use to the historian in verifying dates, and mathematical astronomers have employed them in correcting the lunar tables, or intricate mathematical data by which the motion of the moon is predicted. Coming down to the middle of the 6th century, we find the first eclipse recorded in England in the Saxon Chronicle, AD 538. During the epoch of the Arabian Nights, several eclipses were witnessed at Baghdad, AD 829 to 928, and many a century later by Ubu Junus, court astronomer of Hakem, the Caliph of Egypt. Nothing is more interesting than to research the quaint records of these ancient eclipses. One occurring in 1560, when Tycho Brahe was but 14, had much to do with turning his permanent interest towards mathematics and astronomy. The eclipse of 1612 was the first seen through a tube, the telescope having been invented only a few years before. Paradise Lost was completed about 1665, and the censorship was still in existence, and it is matter of record that the oft-quoted package, as when the sun, new risen, looks through the horizontal misty air, shorn of his beams, or from behind the moon, in dim eclipse, disastrous twilight sheds, on half nations, and with fear of change perplexes monarchs, was strongly urged as sufficient reason for suppressing the entire epic. London was favoured with the outflashing corona, May 3rd, 1715, and a pamphlet was issued in prediction entitled The Black Day, or Prospect of Doomsday. The first American eclipse expedition was on occasion of the totality of October 27, 1780, sent out by Harvard College and the American Academy of Arts and Sciences under Professor Samuel Williams to Penobscot. There was a fine total eclipse from Albany to Boston on June 16, 1806, and many important observations of it were made in this country. But it was not till the European eclipse of 1842 that research got fully underway, because the germ of the new astronomy, particularly as applied to the sun, had begun its development, and the significance of the corona was obvious, if it could be proved a true appendage of the sun. Photography had not long been discovered, and the corona of 1851 was the first to be automatically registered on a daguerreotype. In 1860 it was proved that prominences in corona both belonged to the sun and not to the moon. The great Indian eclipse of 1868 brought the important discovery that the prominences can be observed at any time without an eclipse by means of the spectroscope. In 1869, bright lines were found in the spectrum of the corona, one line in the green indicating the presence of an element not yet known on the Earth, and hence called coronium. In 1870, the reversing layer, or stratum of the sun, was discovered. In 1878, a vast ecliptic extension of the streams of the corona, many millions of miles both east and west of the sun, was first seen. This is now known to be the type of corona characteristic of minimum spots on the sun. In 1882, the spectrum of the corona was first photographed, and in 1889, excellent detailed photographs of the corona were taken. In 1893, it was shown that the corona quite certainly rotates bodily with the sun. In 1896, actual spectrum photographs of the reversing layer established its existence beyond doubt. Flash spectrum, it is often called. In 1898, the long ecliptic streamers of the corona were successfully photographed for the first time. In 1900, the depth of the reversing layer was found to average 500 miles. The heat of the corona was first measured by the bolometer, and many observations showed that coronal streamers, in part at least, partake of the nature of electric discharges. All subsequent total eclipses have been carefully observed in whatever part of the world they may happen, and each has added new results of significance to our theories of the corona and its relation to the radiant energy of the sun. In very recent eclipses, the cinematograph has been brought into action as an efficient adjunct of observation. In 1914, the first successful movie of the eclipse was secured in Sweden, and in 1918, Frost of the Yerkes Observatory first applied the cinematograph to registry of the flash spectrum, and Stebbins tested out his photoelectric cell on the corona, making the brightness 0.5 that of the full moon. In 1914, Russia, and again in 1919 on the Atlantic, the obvious advantages of the aeroplane in ecliptic observations and photography were sought by the writer, though unsuccessfully. The photographic tests, however, conducted in preparation for these expeditions, proved the entire practicability of securing eclipse results of much value, independently of clouds below. Eclipses in the near future will be total in Australia, about 6 minutes on September the 21st, 1922. In California and Mexico, about 4 minutes on September the 10th, 1923. And along a line from Toronto to Nantucket, about 2 minutes on the morning of January 24th, 1925. To all spectators, savage or civilized, scientist or layman, a total eclipse is wonderful and impressive. Langley said, the spectacle is one of which, though the man of science may prosaically state the facts, perhaps only the poet could render the impression. Very gradually the moon steals its way across the face of the sun. The lessened light is hardly noticed. If one is near a tree through which foliage the sunlight filters, an extraordinary sight is seen. The ground all about is covered with luminous crescents, instead of overlapping disks which were there before the eclipse came on. In both cases there are images of the disk of the sun at the time, and the narrowing crescents will be watched with interest as totality approaches. Then the shadow bands may be seen flitting across the landscape like visible wind. They are probably related to our atmosphere, and the very slender crescent from which true sunlight still comes. Then for a few seconds the moon's actual shadow may be caught in its approach. Very suddenly the darkness steals over the landscape and totality is on. How lucky if there are no clouds. Every eye is riveted on the incomparable corona, a silvery soft, unearthly light, with radiant streamers stretching at times millions of uncomprehended miles into space, while the rosy flaming protuberances skirt the black rim of the moon in ethereal splendor. Then it is now or never with observer and photographer. Months of diligent preparations at home, followed by weeks of tedious journey abroad, with days of strenuous preparation and rehearsals at the station, all go for naught, unless the whole is tuned up to perfect operation, the instant totality begins. It may last but a minute, or even less. In 1937, however, total eclipse will last 7 minutes 20 seconds, the longest ever observed, and within half a minute of the longest possible. All is over as suddenly as it came on. The first thing is to complete records, develop plates, and see if everything worked perfectly. There was great utility back of all eclipse research, on account of its wide bearing on meteorology and terrestrial physics, and possibly the direct use of solar energy for industrial purposes. With this purpose in view, the astronomer devotes himself unsparingly to the acquisition of every possible fact about the sun and his corona. Considering the Earth as a whole, the number of total eclipses will average nearly 70 to the century. But at any given place, one may count himself very fortunate if he sees a single total eclipse, though he may see several partial ones without going from home. Then too there are annular or ring eclipses, averaging 7 and 8 years. But had one been born in Boston or New York in the latter part of the 18th century, he might have lived through the entire 19th century and a long way into the 20th without seeing more than one total eclipse of the sun. In London in 1715, no total eclipse had been visible for 6 centuries. However, taking general averages and recalling the comparatively narrow belt of total eclipse, every part of the Earth is likely to come within range of the moon's shadow once in about 3.5 centuries. The longest total eclipses always occur near the equator. This is because an observer on the equator is carried eastward by the Earth's rotation at a velocity of about 1,000 miles per hour, so that he remains longer in the moon's shadow, which is passing over him in the same direction, with a velocity about twice as great. The general circumstances of total eclipses are readily foretold by means of the ancient Chaldean period of eclipses known as the Saros. It is 18 years and 10 or 11 days in length, according to the number of leap years intervening. In one complete Saros, 41 solar eclipses will generally happen, but only about 1/4 of them will be total. The Saros is a period at the end of which the centers of sun and moon return very nearly to their relative positions at the beginning of the cycle. So in general, the eclipse of any year will be a repetition of one which took place 18 years before. and another very similar in circumstances will happen 18 years in the future. 3 periods of the Saros, or 54 years and 1 month, will usually bring about a return of any given eclipse to any particular part of the Earth, so far as longitude is concerned, though the returning track will lie about 600 miles to the north or south of the one 54 years earlier. Paths of total eclipses frequently intersect, if large areas like an entire country are considered. Spain, for instance, where total eclipses have occurred in 1842, 1860, 1870, 1900, and 1905. Besides crossing Spain, the tracks of totality on May 28, 1900, and August 30th, 1905, were unique in intersecting exactly over a large city, Tripoli and Barbary, on both of which occasions the writer's expeditions to that city were rewarded with perfect observing conditions in that now Italian province on the edge of the Great Desert. Kepler was the first astronomer to calculate eclipses with some approach to scientific form, as exemplified in his Rudolphine tables. His method was of course geometrical, but Lagrange, who applied the methods of more refined analysis to the problem, was the first to develop a method by which an eclipse and all its circumstances could be accurately predicted for any part of the Earth. To many minds, the prediction of eclipse affords the best illustration of the superior knowledge of the astronomer. It seems little short of the marvelous. But recalling that the motion of the moon follows the law of gravitation, and that its position in the sky is predictable for years in advance, with a high degree of precision, it will readily be seen how the arrival of the moon's shadow, and hence the total eclipses of the sun, can be foretold for any place over which the shadow passes. All these data derived by the mathematician are known as the elements of the eclipse, and they are prepared many years in advance and published in the nautical almanacs and astronomical ephemerides issued by the leading nations. Buchanan's treatise on eclipses will supply all the technical information regarding the prediction of eclipses that anyone desirous of inquiring into this phase of the problem may desire. So important to total eclipses in the scheme of modern solar research, and so necessary are clear skies in order that expeditions may be favored with success, that every effort is now made to ascertain the weather chances at particular stations along the line of eclipses many years in advance. This method of securing preliminary cloud observations for a series of years has proved especially useful for the eclipses of 1893, 1896, 1900, and 1918. And had it been employed in Russia for totality of 1914, many well-equipped expeditions might have been spared disaster. The California and Mexico totality of 1923 does not require this forethought, as the regions are quite likely to be free from cloud. But observations are now in process of accumulation for the total eclipse of 1925. The lookout for clear skies on that occasion, the total eclipse nearest New York for more than a century, is not very promising. The path of totality passes over Marquette, Michigan, Rochester, and Poughkeepsie, New York, Newport, Rhode Island, and Nantucket about 9 in the morning. Everyone who saw it will remember the last total eclipse in this part of the world, on June 8, 1918, visible from Oregon to Florida. Many will recall the last total eclipse that was visible before that, in the eastern part of the United States, on May 28, 1900, visible in a narrow path from New Orleans to Norfolk. One's father or grandfather will perhaps remember the total eclipse of July 29, 1878, which passed over the United States from Pikes Peak to Texas. It was the writer's maiden eclipse, and another on August 7, 1869, which passed southeasterly over Iowa and Kentucky. On all these occasions, the paths of total eclipse were dotted with numerous observing parties, many of them equipped with elaborate apparatus for studying and photographing the solar corona and prominences, together with a multitude of other phenomena which are seen only when total eclipses take place. Looking forward rather than backward, a striking series or family of eclipses happens in the future. It is the series of May 1901 and 1919, recurring again on June 8, 1937, over the Pacific Ocean, June 20th, 1955, through India, Siam, and Luzon, and June 30th, 1973, visible in Sahara, Abyssinia, and Somali. Already in 1919, this totality was 6 minutes 50 seconds in duration. In 1937, as already mentioned, it will be 7 minutes 20 seconds, and at the subsequent returns even longer yet, approaching the estimated maximum of 7 minutes 58 seconds, which has never been observed. This remarkable series of total eclipses is longer in duration than any others during 1,000 years. Its next subsequent return in 1991, occurring with eclipsed sun practically at noon in the zenith of Mount Popocatépetl in Mexico. Whatever may be the progress of solar research during the intervening years, it is impossible to imagine the alert astronomer of that remote day without incentive for further investigation of the sun's corona, in which it concealed no doubt many secrets of the sun's evolution from nebula to star. Chapter 31, The Solar Corona. And what is the sun's corona? Mildly asked a college professor of a student who might better have answered, not prepared. I did know, Professor, but I have forgotten, was his reply. What an incalculable loss to science, returned the professor with a twinkle. The only man who ever knew what the sun's corona is, and he has forgotten. Only in part has the mystery of the corona been cleared by the research of the present day. Our knowledge proceeds but slowly, because the corona has never been seen except during total eclipses of the sun, and astronomers, as a matter of fact, have never had a fair chance at it. 2 total eclipses happen on the average of every 3 years. The average duration is only 2 or 3 minutes. Totality can only be seen in a narrow path about 100 miles wide, though it may be several thousand miles long. There is usually about the equal chance of cloud with clear skies, with fully 3/4 of the totality areas of the globe are unavailable, covered by water. So that even if we imagine the tracks of eclipses quite thickly populated with astronomers and telescopes, at least one every 100 miles, how much solid watching of the corona would this permit? Only a little more than 1 week's time in a whole century. The true corona is at least a triple phenomenon, and a very complex one. The photographs reveal it much as the eye sees it, with all its complexity of interlacing streamers projected onto a flat or plane surrounding the disk of the dark moon, which hides the true sun completely. But we must keep in mind the fact that the sun is a globe, not a disk, and that the streamers of the corona radiate more or less from all parts of the surface of the solar sphere, much as quills from a porcupine. From the sun's magnetic poles branched out the polar rays, nearly straight throughout their visible extent. Gradually, as the coronal rays originate at points around the solar disk, further and further removed from the poles, they are more and more curved. Very probably they extend into the equatorial regions, but it is not easy to trace them there, because they are projected upon and confused with the filaments, having their origin remote from the poles. Then there is the inner equatorial corona, apparently connected intimately with truly solar phenomena, quite as the polar rays are. The third element in the composite is the outer ecliptic corona, for the most part made up of long streamers. It is most fully developed at the time of the fewest spots on the sun. It is traceable much further against the black sky with the naked eye than by photography. Without any doubt it is a solar appendage, and possibly it may merge into the zodiacal light. Naturally, this superb spectacle must have been an amazing sight to the beholders of antiquity who were fortunate enough to see it. Historical references are rare. Perhaps the earliest was by Plutarch, about AD 100, who wrote of it, "A radiance shone around the rim and would not suffer darkness to become deep and intense." Philostratus, a century later, mentions the death of the Emperor Domitian at Ephesus, as announced by a total eclipse. Kepler thought the corona was evidence of a lunar atmosphere. Indeed, it was not until the middle of the 19th century that its lack of relation to the moon was finally demonstrated. Later observers, Weibird in 1652 and Aloha, got an impression that the corona turned around the disk Catherine wheel fashion, like an ignited wheel in fireworks turning on its center. But no later observer has reported anything of the sort. Quite the contrary, there it stands against the black sky, in motionless magnificence, a colorless pearly mass of wisps and streamers, for the most part nebulous and ill-defined, fading out very irregularly into the black sky beyond, but with a complex interlacing of filaments, sometimes very sharply defined near the solar poles. It defies the skill of the artist and draftsman to sketch it before it is gone. Photograph it? Yes, but there are troubles. Of course, the camera work is superior to sketches by hand. As Langley used to say, the camera has no nerves, and what it sets down we may rely on. Foremost among the photographic difficulties is the wide variation in intensity of the coronal light in different regions of the corona. If a plate is exposed long enough to get the outer corona, the exceeding brightness of the inner corona overexposes and burns out that part of the plate or film. If the exposure is short, we hit certain regions of the inner corona excellently, but the outer regions are a blank, because they can be caught only by a long exposure. So the only way is to take a series of pictures with a wide range of exposures, and then by careful and artistic handwork, combine them all into a single drawing. Wesley of London has succeeded eminently in work of this character, and his drawings of the sun's corona, visible at total eclipses from 1871 onward, in possession of the Royal Astronomical Society, are the finest in existence. They give a vastly better idea of the corona, as the eye sees it, than any single photograph possibly can. The early observers apparently never thought of the corona as being connected with the sun. It was a halo merely, and so drawn. Its real structure was neither known, depicted, or investigated. Sketches were structureless, as any aureola formed by stray sunlight grazing the moon might naturally be. That the rays are curved and far from the radial around the sun was shown for the first time in the sketches of 1842. And in 1860, Sir Francis Galton observed that the long arms of streamers do not radiate strictly from the center. The inner corona had first been recorded photographically on a daguerreotype plate during the eclipse of 1851, but the lens belonged to a heliometer and was of course uncorrected for the photographic rays. The wet collodion plates of the eclipse of 1860 by De La Rue proved that not only the prominences, but the corona were truly solar, because a series of technically perfect pictures revealed the steady and unchanged character of these phenomena, while the moon's disk was passing over them as totality progressed. And at the eclipse of 1869, Young put the solar theory of the corona beyond the shadow of any further doubt, by examination of its light with a spectroscope, and discovering a green line in the spectrum due to incandescent vapor of a substance not then identified with anything terrestrial, and therefore called coronium. The total brilliance of the corona was very differently estimated by the earlier observers, though pretty carefully measured at later eclipses. The standard full moon is used for reference, and at one eclipse the corona falls short of, while at another it will exceed the full moon in brightness. Variations in brilliancy are quite marked. At one eclipse it was nearly 4 times as bright as the full moon. Much evidence has already been accumulated on this question, but whether the observed variations are real or due mainly to the varying relative sizes of sun and moon at different eclipses is not yet known. The coronal light is largely bluish in tint, and this is the region of the spectrum most powerfully absorbed by our atmosphere. Eclipses are observed by different expeditions located at stations where the eclipsed sun stands at very different altitudes above the horizon. Besides this, the localities of observation are at varied elevations above sea level, so that the varying amount of absorption of the coronal light renders the problem one of much difficulty. The long ecliptic streamers of the corona were first seen by Newcomb and Langley during the totality of 1878. On one side of the sun there was a stupendous extension of at least 12 solar diameters, or nearly 11 millions of miles. Langley observed from the summit of Pikes Peak, over 14,000 feet high, and was sure that he was witnessing a real phenomenon heretofore undescribed. The vast advantage of elevation was apparent also from the fact that he held the corona for more than 4 minutes after true totality had ended. These streamers are characteristic of the epoch of minimum spots on the sun, as Rain had first suggested. It was found that this type of corona has been recorded also in 1867, and it has reappeared in 1889, 1900, and 1911, and will doubtless be visible again in 1922. How rapidly the streamers of the corona vary is not known. Occasionally an observer reports having seen the filaments vibrate rapidly, as in the aurora borealis, but this is not verified by others, who saw the same corona perfectly unmoving. Comparisons of photographs taken at widely separate stations during the same eclipse have shown that at least the corona remains stationary for hours at a time. Whether it may be unchanged at the end of a day or a week or a month is not known, because no two total eclipses can ever happen nearer each other than within an interval of 173 days, or 1/2 of the eclipse year. And usually the interval between two eclipses is twice or 3 times this period. Theories of what the solar corona may be are very numerous. The extreme inner corona is perhaps in part a sort of gaseous atmosphere of the sun, due to matter ejected from the sun and kept in motion by forces of ejection, gravity, and repulsion of some sort. Meteoric matter is likely concerned in it, and Huggins suggested the debris of disintegrated comets. Schuster was in agreement with Huggins that the brighter filaments of the corona might be due to electrical discharges, but it seems very unlikely that any single hypothesis can completely account for the intricate tracery of so complex a phenomenon. Elaborate spectroscopic programs have been carried out at recent eclipses, affording evidence that certain regions are due to incandescent matter of lower temperature than the sun's surface. A small part of the light of the corona is sunlight reflected from dark particles, possibly meteoric, but more likely dust particles or fog of some sort. This accounts for the weakened solar spectrum, with Fraunhofer absorption lines, and this part of the light is polarized. Many have been the attempts to see or photograph the corona without an eclipse. None of them has, however, succeeded as yet. Huggins got very promising results nearly 40 years ago, and success was thought to have been reached, but subsequent experiments on the Riffelberg in 1884, and later, convinced him that his results related only to a spurious corona. In 1887, the writer made an unsuccessful attempt to visualize the corona from the summit of Mount Fujiyama, and Hale tried both optical and photographic methods on Pikes Peak in 1893 without success. He devised later a promising method by which the heat of the corona in different regions can be measured by the bolometer, and an outline corona afterwards sketched from these results. Still another method of attacking the problem occurred to the writer in 1919, which has not yet been carried out. It would take advantage of recent advances in aeronautics and contemplates an artificial eclipse in the upper air by means of a black spherical balloon. This would be sent up to an altitude of perhaps 40,000 feet, where it would partake of the motion of the air current in which it came to equilibrium. Then a snapshot camera would be mounted on an aeroplane, in which the aviator would ascend to such a height that the balloon just covered the sun, as the moon does in a total eclipse. With the center of the balloon in line with the sun's center, he would photograph the regions of the sky immediately surrounding the sun, against which the corona is projected. As the entire apparatus would be above more than an entire half of the Earth's atmosphere, the experiment would be well worth the attempt, as pretty much everything else has been tried and found wanting. Needless to say, the importance of seeing the corona at regular intervals whenever desired, without waiting for eclipses of the sun, remains as insistent as ever. And at the end of that chapter, and the end of something rather interesting, I'm going to call it a night. As always, and as usual, if you'd like to pick up where I'm leaving off, you can find the original on Project Gutenberg at the link in the show notes. Thanks again for joining me on this episode of Sleepy Time Tales, the podcast designed around a bedtime story to help you to get a restful night. New episodes will be released every Sunday night to give you something fresh to help you rest in a new week. But make sure to follow or subscribe in whatever service you use so that you get your new episodes whenever they come out. Good night and sweet dreams.